power series and like what a power series is, okay? And then the second part of that is that we can rewrite things as power series, as well as sometimes we need to manipulate power series using different operations. So instead of saying like manipulating power series, I just said operations with power series. Because sometimes that involves like multiplying or dividing. Every once in a while it'll be adding or subtracting, but mostly it's going to be multiplying or dividing or taking the derivative or integral of a series. So this is just, we can do some of these things, okay? And we're going to look at like why those are helpful and things like that. But let's first look at, so it says find a power series for f of x equals 6 divided by x plus 2, centered at x equals 0. Give the first 4 non-zero terms and the general term, and then find the interval of convergence. That's a lot. Very good. So right now we don't have a series. So we need to help us ourselves make a series. And for this one, what we're actually going to do is we're going to try to make that f of x look like something that we know is a series. So what is one of the big series that we talk about? One of our like very first series that we talked about. No, like last unit first series that we talked about. Before that. Yeah, geometric series. And the reason why the geometric series is helpful is because, remind me, what does our sum of a geometric series equal? We get that. Yes? And remember that we're trying to write a sum or a series, yes, to represent this f of x. So in other words, I want my f of x to equal that. And the reason we picked this is because notice that I already have something that looks fairly like what the right side equals. Yes? And so this is why we chose the geometric, to manipulate what we have to look like that. So the first thing we need to do, though, is if I'm looking at f of x, so we're not quite in the correct form. So first I'm going to switch my constant and my x. And then what do I need that to be? 1. So what would I do? Ish. Multiply by 1/2. And I do it that way because remember I have to do it to the top and the bottom. Because I can't actually change what that thing is. I can just manipulate or rewrite it so that it looks like the form that I need it to be in. So now I have a 3 on top and a 1 plus, now I have an x divided by 2 on bottom. Then what's the last thing that's kind of wrong? Yeah, I have subtraction, or I have addition, I need subtraction. How can I rewrite addition as subtraction? But, not quite. Plus a negative is subtraction. I need it minus a negative, yeah. So I get something that looks like that. Yes, oh baby. And it asks us to give the first 4 terms and then the general term. I actually think it's a little bit easier to go backwards. Because remember, what is our general term for a geometric? makes sense because remember our power series are going to have x's in them. That's kind of the point. Right, because I'm trying to rewrite a function as a series, my function has x's in it, which means my power series has to have x's in it. But then it asks us to rate the first for a term, non-zero term. And remember, for our power series, we start with an n of what? Zero. So what would our first term be? Just 3. What would our second term be? Yeah, so this would be negative x over 2 to the first power, right? But remember with our series, we tend to write it as the number first. So we have a negative 3/2, and then it's just x to the first power. So then what comes next? Plugging in 2. So it's going to be positive this time. My 3 is going to stay the same, but now I have 2 squared, which is going to give us a 4. X to the second power. How many terms did it say we needed? 4. How many do we have right now? 3. So we need 1 more. We're going to alternate again to negative. This time it'll be 3 over 8. Because remember, it's the power, right? I'm raising 2 to the third power. Times x to the third. Yes, because my 2 is inside of my exponent. So I'm raising it to the third power. So you're conflating Taylor polynomials and power series. It did not ask me to write out a Taylor polynomial with this. We said that we can write our Taylor series, or write our Taylor polynomials as a power series, but that's not what we're doing here. I'm just writing out this function as a power series. Yes? No, maybe? So remember, our power series was, I had the sum of a sub n times x minus c to the n, from n equals 0 to infinity, where c is your center, and in this case our center was 0, so that's why I said x to the n. Now, this is going to look similar to our Taylor polynomials because we can write Taylor polynomials as a power series, which is what we're doing in next section. But kind of like with the square rectangle things, right? Like all Taylor series are power series, but not all power series are Taylor series. Does that make sense? Okay. But then what's the last thing that it asks us to do? Ooh, okay. So what do we know about geometric series again? When do they converge?
When R is less than
Mm-hmm. And so what is, well, it's not just R, it's the absolute value of R. And in this case, what is our R? Okay? So is that negative gonna matter all that much at the end of the day? No. So I get x divided by 2. But what am I going to have to create in order to drop all of the absolute value? Compound inequality. So it does have an upper bound of 1, but it will also have a lower bound of negative 1. So what do we get then? Negative 2 to 2. symmetric series as these, notice that my x cannot be negative 2 and 2 because it's on the bottom and that gives a 0 on the bottom and that's bad. So I don't even have to check them, which is kind of nice with these. Okay. Just a side note, what would our R be here? 2, okay? We dealt with a lot that had an R of 1, so like this is just a good example where our R is not 1. It would be 2 this time. What questions do we have? Okay. Again, this stuff is very different than a lot of the stuff that we've looked at in the past. So that's why, even though it's not my favorite to have to push stuff back, I also don't want us to like race through stuff. I want us to have time to kind of digest what we're looking at with these. So it says given f of x, find a Maclaurin series for f of x. So I have f of x equals e to the negative 2x. So again, we're talking about manipulating series that I kind of already know. Yes? What's one of our special series that we're supposed to know? E to the x. Does that look similar to e to the x?
Yes.
Yeah. Okay. What is our e to the x as a series?
X to the
Backwards. From n equals 0 to infinity. Yes, I'm moving.
Yes.
So instead of an x, what do we have? Negative 2x. Okay. Now, some of us had a hard time with this when we were doing our estimations from Maclaurin polynomials. Okay. So be careful here, right? So technically, right, what did I replace in my function? The x value, right? Like I already had an e, this already has an e, so I just replaced the x value. Are we with me? Which means that I'm also just replacing the x value on my summation. Does that make sense? Like this formula already takes care of the e, the only difference is what I have for x. Are we all okay with that? Okay, so with that in mind, we said that we have to replace our x with a what? Negative 2x. But we do still want to write it in like power series notation. So remember, that's where I have like numbers and ends, and then I need my x to kind of be separate. Yes, no, maybe. We're not okay with that. So how would I separate that? So like if both of these are being raised to the n power right now, yeah? I could also just rewrite this as like negative 2 to the n divided by n factorial times n x to the n. Yes, no, maybe? Because now this is centered at 0, so that's why I just have an x, and then this thing now is acting as my a sub n. Yes, no, maybe? And you're fine to leave it like that, like for your response question, that's fine. Just know that sometimes on the multiple choice, okay, remember that our standard, like the way they tend to like it, write it when there's a negative, is that they would separate these out. But I mean, like, notice those are the same thing, and you're fine to leave it here. It's just like if it was multiple choice, a lot of times they're gonna pull that -1 out, so that it's easier to see that it is an alternating series. I would do that. And then again, it doesn't ask us to write out the terms, but if I wanted to, right, we start at 0, so I would just get a number, then I would plug in 1 or 2 or so forth, and however many terms it needed to have. What questions do we have there? So that was our manipulating. We'll stop there for today, so you have time to take your CFA. Tomorrow we will look at some